bulk enhancement MOSFET, extrinsic DS diffusion diodes, base source gate, extrinsic DS diffusion diode. This is it. So here LD, XD, X distance diode, length diode, N plus, this N plus, and then PD, JD, P-well, this is P-well. Geometry parameters, AD, geometry parameters, this AD equal to W, LD, WLD, this distance, and then width. Multiply with the width, that one is area. Then PD, this PD equal to 2W plus this LD. For perimeter, JJ equal to AD, PD, DXD. This is PD side walls. Okay. AD bottom plate. This is AD bottom plate. That in the reverse leakage current, ID equal to AD JS ADJS BDP AE power PM minus BDP UT minus 1 plus PD XD, this PD XD JSW E power minus BDP divided by UT minus 1. Deflection capacitance CD equal to AD CJ divided by 1 minus BDP divided by PP MJ plus PD XD CA CJSW 1 minus VDP divide PP SW whole power MJ SW. Okay, MJ only. Sequential EKV model extraction sequential methodology to minimize errors. Sequential methodology to minimize errors. Preliminary extraction, wide lock, wide short, narrow lock, narrow short. In preliminary extraction of DL, TW, RS sketch from several geometries. Then it will connect to wide lock. Here, under wide lock, specific current measurement. VP versus VG, VTO, gamma, pi. ID versus VG, KP, V0. IB versus VG, IBA, IBB, IBN. It will connect to wide short. Specific current measurement, VP versus VG. Length, vector Q0, LK. ID versus VD, UCRIT, lambda. It will connect, this connect to narrow block. Under this specific current measurement, VPS, VCS, VG, vector, and this one connected to here narrow short. After final check and fine tuning. With length array, WL array of transistors to adjust model stability. With length array of transistors to adjust model scalability. What is this mean? W array of transistors adjust the model scalability. Narrow short, wide short, wide log, narrow log. PKV model extraction, sequential methodology to minimize errors. Here, sequential methodology to minimize error. Here, specific current measurement, PP versus VG, VPO gamma phi. And then what we are doing here? KVM model extraction, specific current estimation. Here, in x-axis log ID log. In y-axis GMS VT underscore VT underscore 1M GMS underscore VT underscore 1 dot S 10 power minus 12 to 10 power minus 1 11 10 power minus 10 10 power minus 9 10 power minus 8 10 power minus 7 10 power minus 6 10 power minus 5 10 power minus 4 10 power. Here GMS underscore VT underscore 1 may M GMS underscore VT underscore 1 S 618 log. Here 10 power minus 12 10 power minus 1 10 power 0 10 power 1. This is the 0 here. Yes. No straight line, that one. This is term inversion, weak inversion. Okay. Here GMS UT cos UT ID. That is this is the weak inversion part. This is inversion strong inversion GMS into UT by ID. Okay. In these equations, GMS equal to into UT divided by ID. This GMS, this will take. Okay. Then 1 by 4 plus IC 1 divided here 1 by 4 plus IC plus 1 by 2. These all value to be square root square equal to 1 when IC is less than 1. And another when 0.618 is get for this value as when IC equal to 1. This is the condition. Here actually GMS in the UT divided by ID equal to 1 by 4 plus IC I have 1 by 2. That got result 1.618. EKV model extraction. Example, specific current estimation, threshold voltage estimation. Here, strong inversion. This is weak inversion. Here weak inversion. Here strong inversion. This is GMS UT by ID. Here 10 power minus 10, 11, 10 power minus 5, 10 power minus 4. Log start resistance. Log 1. Okay. ID log GMS underscore VT underscore 1 by 10 GMS in this direction. So plug find large GMS ID. Okay. And then due to weak inversion going like this. And then threshold voltage estimation. Here in x-axis VG CE plus 0. Here VS dot M VS dot S. Y-axis. Here this is VTO by this one here. Okay, VTO gamma. This is gamma. This is VTO. PI, PHI. VG equals theta. Here VG gate. Here base Vs minus Vp. Okay, IB equal to IS divided by 2, the half percent. Then N theta U T square. Private components. Coplanar capacitors. Coplanar capacitors. Interlayer. Thin insulator. Low ohmic connectors. L. This is L or W. Here W or L. L. Sorry, not L. L. Here multiplication M. Here 1. Here WC. Sorry, only C. Here okay. Then first top plate E bar, up to here T, here H not switchable, bottom plate direction this side only, down side only. Overlap plus fringy capacitance, vertical permittivity F of C equal to M of epsilon divided by H WL plus 4 by epsilon of W plus L divided by